We surely are beginning our discussion right now. In beginning our discussion, once again, we look at what we call the two-way tables, Venn diagrams, tree diagrams, sequences, and series. Right, so we look at probability. These are the tools we use to study probability. And it's very important that we understand the tools very well. We get started. Right, as part of what you need to learn, these two-way tables are very important for us to understand them. In a survey of 1,530 skydivers were asked if they had broken a limb. The results of the survey were as follows. So you have the results of the survey, they as shown. Right, so you have the male, you have the female, you have the totals, you have the broken limb, not broken limb, the totals. Male, broken limb, not broken limb, the total is 782. Female, broken limb, not broken limb, total is D. The broken limb total is 913, not broken limb total is 617, total is 1530. Calculate the values of A, B, C, and D. Right, so we look at these very carefully and we ensure that we can be able to do the calculations here and to comfortably be able to answer this question. What is the numerical value of A? Right, looking at this question, we're able to see clearly that the value of A is that which when you add to 463, 463 plus A must give us 913. And A can only be 450 because of 450 plus that is plus 463 is 913. And then that means that we shall be able to answer this question and realize therefore that our A is equal to 450. I've made enough space for us to answer the question. So we've already seen that A here is 450. And therefore here we have that our A is 450. B, okay. B is that when you add 463, you get 782. What must B be? 319. Because 463 plus 319 gives us 782. So what is our B here? Our B is 319. What is our C? Right, our C is that when we add to the B, B plus C must be 617. So clearly here our C must be 298 because 298 plus 319 is that one there. Right, so we're good. We're so good. Right, I think I need to invite Bupilo as well, and Bupilo be with us here because we're doing probability. Probability is there both ways. So I want to invite Bupilo. To be with us. I want to invite Bupilo to be with us. Yes, can you join our discussion now on Zoom? Yeah, because I'm having Tenulo. But yeah, I wanted you to join us as well. We're discussing common things.
Wait, okay.
Okay, that's fine. I'll get back to you when we're done then so that you can fix it. Okay. Okay, sharp Pupilo. All right. Pupilo is saying it doesn't download this Zoom thing, is not working on her phone. I will check that. Okay, I wanted her to be part of us. Okay. Now D must be the number which, when added to 782, gives us 1530. And D is actually 748. So 782 plus 748 gives us 1530. Well, we were saying C is 298, but we're also saying D is 748. Okay. So this sort of gives us the answers we need. The next thing we're going to do, so what was the question? Calculate the values of A, B, C, and D. We found A, we found B, C, and D. We found those. So we're done with 5.1. Think about whether you understand or not and ask questions. Right, so we move on to the next question. We move on to the next question. And the next question is about more learning and more understanding, so that we can be in a position to understand the things very, very well. Because we need to make sure that people understand the work so that they can become very good learners. I'm spending time showing this screen because we've done a series of calculations. To me, it is very important that you understand every single bit of thing on the screen. Next question. Okay, we have found already the numerical values of A, B, C, and D, and we can even quote them here. We need to now calculate the probability of choosing at random in the survey a female skydiver who has not broken a limb. So we analyze that one together. Okay, let's first start with the A. So A here is a number which you can add to 463 to get 913, and we saw that A is 450 because 450 plus 463 is 913. B is 319, right, 319, and we found C to be 298 from the previous question. I'm just writing those down and filling the table up. Right, so this one is this D is 748. Now, with that said, here we are continuing to say calculate the probability of choosing at random in the survey a female skydiver who has not broken a limb. So we're looking at a female skydiver who has not broken a limb. So we are here. Right, so the probability P of a female um skydiver who has not broken a limb. A female skydiver who has not broken a limb. Right, so we good. Who has not broken a limb. So what is the probability here? The probability would be female, not broken a limb, 298. The total of everything, the total of everything. What is the total of everything? 1530. Yeah, 1530. Yeah. Um, if you simplify this here, This simplified fraction is 149 divided by 765. Okay. So that becomes the answer. There comes the answer. Next. So we found a probability here. The next probability is yours. I'm giving it to you to try with me. The same question still persists, and we found I was just putting the table here to make sure we can fill it in, because the table is the tool we use to organize the information. A is 450, B is 319, C is 298, D is 748. So in a survey, 1530 skydivers were asked if they'd broken a limb. The results of the survey were as follows. Broken a limb, 450 plus 463 is 913. 319, 298, 617. 782, 748, you add, you get 1530. 1530 there. Okay. Is being a female skydiver and having broken a limb independent? Use calculation. So we're looking at independent events, right? So use calculations corrected to decimal places to motivate your answer. So now we are looking at a female skydiver broken a limb. Right, so if we let Fs, right, if we let Fs become the following, we let Fs to actually mean female skydiver, right? Then we have broken a limb, broken a limb. Okay, are they independent? Use calculations correct to decimal places to motivate your answer. The probability of female skydiver, right? Female skydiver who has not broken a limb is what? Okay. Right, I'm having Ayanda here joining us as well, because Ayanda had to join us earlier, but it's okay. Right. So we continue. We continue. We continue. Right, so we continue right now, and we are saying, at this point, a female skydiver who has not broken a limb is going to become what? Right, so you look at the female skydiver who has broken a limb. That's what I want to consider first. Female skydiver who has broken a limb. Right, so right, it's being a female skydiver having broken a limb. Are these actually independent events? So let me write it as follows and say, we are looking at a female skydiver and broken a limb. Right. So that is going to become female skydiver and broken a limb. Female skydiver having broken a limb. So you have to look at the fact that female broken a limb. How many? 450. So you put 450 here. You divide everything by total of everything, 1530. Simplifying this fraction here is going to become 5 out of 17. Okay. And 5 out of 17 is the same as approximately what? Using calculator is 0.29, 294, 11, 764, 71. Let's look now at the probability. Right, let's say this discussion is being recorded in case the network is not so good. The probability of a female skydiver times the probability of broken a limb. What does independent events mean? So by independent events in mathematics and statistics, we mean that the probability of A and B is the probability of A times the probability of B. So this can also be written as the probability of, come here, the probability of A and B. Okay, if we can also write the and like I have just done now. We can just write the end as I've just done right now. So if you write the end as I've just done now, you have that. Okay. The probability of A and B is the probability of A multiplied by the probability of B. So obviously this here is what we call independent events. This formula is true for independent events. The probability of A and B. So you can use the intersection symbol, and the intersection symbol is the same as the and symbol, a conjunction in English. Right, so what is all this here? The probability of a female skydiver. What is the probability of picking a female skydiver? The probability of actually picking a female skydiver is what? Right, the probability of picking a female skydiver, either broken a limb or not broken a limb, is 748. Divided by the probability by the total summation. Divided by the total summation of every single bit of thing. Okay, what is the probability of broken a limb? Broken a limb probability, or rather, first, how many they have their limbs broken? Broken a limb. How many have their limbs broken all together? Right, so broken limbs broken limbs, the total of the broken limbs is you have the male and the female. Some of the males, because when they do skydiving, when you skydive, sometimes when you actually break your limb, you actually possibly can have your limb broken. Okay. I've seen the answer. Right, I have actually seen the answer in the chats. Thank you for the attempt there. Yeah, you're right. You are on point. Anyway, you're on point. But broken a limb is gonna be broken a limb. Total broken a limb is this one. Broken a limb is this one. 913, 913. Right. So we're good. Broken a limb is gonna be 913. I write that one down. Divided by, so yeah, just divide the screen a little bit here. These numbers are going to get mixed up. And then now, obviously, when you find the probability, divide by the total of everything. Use a calculator is 0.29. Full stop. Okay, we have this system here. And we're asking the question, are these events independent or not? They're going to ask you, are they independent or not? Okay, we're going to look at mutual exclusive events, complementary events, and whatnot. But those ones are too easy. But yeah, we will discuss mutual exclusive to say what does it mean. But independent involves a bit more calculation. So sometimes they like it. It's more popular to speak of independent events in the exams. Okay, so let me divide the screen a little bit here. Let me divide the screen a little bit to finish. I know that I'm writing too much, congesting everything here. So now we can see that if you look at the probability of a female skydiver and broken a limb is 0.29, the probability of female skydiver times broken a limb is 0.29 as well. So yes, the probability of a female skydiver and broken a limb is the same as the probability of a female skydiver times the probability of broken a limb. Yes, independent. Yes, independent since, yes, independent since this is true because the probability of a female skydiver and broken a limb is 0.29, but female skydiver and broken a limb is 0.29. Look carefully. You can see that they're both 0.29 and therefore they compare, they are just almost equal to each other. And in this, at this point, we rounded off to two decimal places, they are equal, and therefore we agreed that the events themselves are independent. So we have discussed what are independent events in statistics. What are independent events in probability? It is when we say the probability of A and the probability of B equals the probability of A times the probability of B. What are mutual exclusive events? I'm going to speak about mutual exclusive events. I'm going to speak about complementary events and other types of events. But first, let's look at the next question. As part of our study, they ask us to look at the Venn diagrams. Right, a survey is conducted among 174 students. The results are shown below. You have 37 study LS, life sciences, 6C study physical sciences, 111, okay, 111 study mathematics, 29 study life sciences and math, 50 study math and physical sciences, 13 study physical sciences and life sciences. Okay, They're asking us to draw a Venn diagram to represent the information. Let's look at the specific question. I want us to answer question set 6.1, but I want us to learn how to draw the Venn diagram in the exam because if they ask you to draw a two-way table, the question I brought here had a two-way table already drawn, but I'm going to bring another question in our next meeting where you need to just draw the two-way table yourself. Then we see how well we can do that. So, those are the kinds of things we do. Okay, a survey is conducted amongst 174 students. The results are shown below. 37 study life sciences. This is exactly question 6. Question 6. But to draw the Venn diagram here, we need to draw big. From here to there. We go across like this. We go down. We run across like this. Right, so we analyze these together. So we understand that we have those who study life sciences, physical sciences, and math. And a combination of somebody doing like math and physical sciences, or they're doing life sciences and math, or another student maybe can do like 45, do not study any of this. So 45 students do not do life sciences, they don't do math, or physical sciences. So there are students who study life sciences, math, and physical sciences. There also don't do any of this because a student can decide to do accounting and not do life sciences. In the place of life sciences, they can do accounting, they can do economics, they can do business studies or something of that sort. So obviously, we are trying to organize the information here. So let's look at these together. Now, we say the students who do, for example, life sciences. Let's call that L. And then there are those students who decide to do physical sciences. And there are those students who decide to do mathematics. Okay, not everybody obviously does mathematics because some people want to do like math leads. So we need to respect their choice of math leads. But some students are like, okay, they want to do I know that these things are not perfect circles. Yeah, they should not be perfect circles anyway. I'm trying to make them a little bit oval, but yeah. Right, so let's look at these now. Let's start and fill in the information. To draw a Venn diagram, we need to fill in the information here and make sure that all is pretty very, very well. But maybe these are not so large enough. Please allow me to make them a bit larger. Let me see if I can make them a little bit larger, but oval. Right, they should not really be perfect circles, but yeah, a little bit oval. Let me give it a try once more. If this one here is going to be just this way here. Little bit like an egg. In this one, that's going to like another little egg. And this one, another egg. Okay, so life sciences, physical sciences, and math. Okay. 37 life sciences, 60 study physical sciences. Yeah. 111 study mathematics. 29 study life sciences and math. 50 study mathematics and physical sciences. 13 study physical sciences and life sciences. 45 do not study any life sciences, mathematics, or physical sciences. X students study life sciences, mathematics, and physical sciences. Okay, X students study, this is the most important thing. So X students would study those, right? So let's look at X students. So X students will study life sciences, mathematics, and physical sciences. So X are here where all these events intersect. Then now we have also, if you have X here, then you can come to this one. 13 students study. Now we look at the ones that are like here, mostly 13 students study physical sciences and life sciences. Physical sciences and life sciences, there must be 13, but you already have X here. So which means that we shall have 13 minus X. Okay. Fifty, study mathematics and physical sciences. Right, if you get the fact that 50 study mathematics and physical sciences. So you have mathematics and physical sciences, there must be 50 of them. Mathematics. So you already have X here, which means it must be 50 minus X. 50 minus X. Because now when you add 50 minus X and X, you get 50. So that you have 50 study mathematics and physical sciences. We're done with this. We're done with the 13. So we shall look at the 45. We're done with the X. 29, study life sciences and math. Okay, life sciences and math, there must be 29. So it means already have X here. These ones are 29 minus X. Okay, because when you add the 29 minus X and this one, they give you 29. Triple 111, study mathematics. So those here in mathematics, they must give you 111. So first you can call this one small m. So that you can say, if they say study mathematics, so yeah, you look at the event for those who do mathematics. So you're gonna say m plus 29 minus x to make it easier, plus x plus 50 minus x plus m. No, yeah. Okay, I obviously add the m once. And therefore this here must be the same as what? It must be the same as the ones who do mathematics. So, and there are 111 of them. Right, and then you have x minus x, which is 0. The x cancel out. Want to solve for m. Want to know how many like do math only. So now you're going to have 29 and 50. But I have 29 and 50. Right. So right. So now you have 29 and 50, which means that you have 111 minus 50, which would be what? It would be like 61. Out of 61, you subtract 30 plus 1. Subtract 30, then 1 less. Right. If out of 111 you subtract 50, you'll get like a 61. And then you subtract 29 in essence. So 60 minus 29. What is the result? 61 minus, so in other words, what we are saying is 111. You do that on your head, minus 29. minus 50. So that is going to give you a 32. It's going to give 32. 111 minus 29 minus 50 is going to give you like 32. And then x minus x is 0. And then you're actually going to add an x like this. 32 plus x. So, yeah, that's how we get 32 plus x. Okay, so we are done with this one of 111. We use the 100, so we must use like all the numbers here. 6 starts with physical sciences. So physical sciences must be 60. So it's the same thing, like we come to this one. There must be 60, everything here. This plus that must be 60. So which means that we're going to do this. We're going to do, call this P, like lowercase p, so that you're going to have 13 minus x plus x plus 50 minus x plus p. It must give you the total for science. Physical sciences, 60. But in the end, then we want to get what P is. How many of those, like if 60 do physical sciences, it's not that they only do physical sciences, okay? But how many only do science, physics, physical sciences? So we subtract. So we're gonna have the 50 and the 13, right? And then the x minus x is 0. The x moved across is gonna be like plus x. Okay, if you have 50 and 50 plus 13, what does it give us? It gives us 63. 60 minus 63 is minus 3. So this one is x minus 3. Okay. All right, so we have this. Right, next. So we're done with 60 for physical sciences. But now let's come to life sciences, because there are 37 of those who do life sciences. There are 37 of them. So if like 37 do life sciences, what is the meaning of this? What is the meaning of this? 37 do life sciences. What is the meaning of these? We analyze together. So, in other words, 37 do life sciences. This, that, and that is life sciences. So let's do the life sciences here. Right. So we're going to do life sciences at the top here. Okay, now life sciences, folks, would be this plus that. Okay, we call this small l. So which means that we're going to have the small l for life sciences. For those who only do life sciences, but some do life sciences and math, life sciences and physics. So which means that you're going to have 29 minus x. We add x. We add 13 minus x. And then, yeah, we add all these. And then when you add all these, the 29, the x, and the 13 minus x, the result must be life sciences total 37. So we get the answer. Okay, x minus x is 0, so that this x here moved across is going to become there. There's 29 and 13. What is 29 plus 13? Okay, 20 plus 10 is actually 30. And so this is exactly like a 42. The 42, it's a 37 minus 42 will give us a 5 negative. X minus 5. X minus 5. So we continue. We continue. Okay, we are not done yet. We did this, we did that one, this one. So it helps to tick so that you can like, okay, we need to deal with the 45 now. Okay, we dealt with the X. Yeah, 45 is the only one that's left. 45 do not study any life sciences, mathematics, or physical sciences. They are 45. So we agree that there are a total of 45 learners who don't do any of those. They do other things. They do like CAT. They do like business studies. They do other things. They do consumer studies. So they do history. They don't then, if they don't do history, decide, okay, they want to do history and math leads. They don't want pure math at all. Okay. Is the Venn diagram complete? Let's check. And the Venn diagram, as drawn here, must have a total of 8 regions. So we need a total of 8 regions. Are all the 8 regions filled in? 1, 2, 3, 4, 5, 6, 7, 8. Yes, all the regions have been built up. And therefore, the question was draw a Venn diagram to represent the information above. We have drawn the Venn diagram. We have represented the information above. And we get the full marks 6 there. Okay, next question. Next question. So that x equals 13, 1, 3. So that x equals 1, 3. So that x equals 1, 3. What is x equals 13? So we would just actually recall something about the Venn diagram we just drew. The Venn diagram we just drew was something of this sort. I'm just going to draw it quickly so that you don't waste a lot of time on the Venn diagram. And it was like this. It was sort of this way. And then it was sort of this way here. And there were a couple of features of interest to us. There was life sciences, there was physical sciences, and there was mathematics. These were x minus 5, and this was only x. This was 13 minus x. This was 29 minus x. This was 50 minus x. This was x minus 3. This was 32 plus x. This was 45. And we had this here. And this is all. So we need to show that 13 is equal to x is equal to 13. Let's show that x equals 13. To show that x equals 13, we proceed as follows. So we add everything together. Right, to add everything together, we need to remember that it's a survey that is conducted among a total of 174 learners, meaning we're going to add everything. So we're going to start by the x minus 5. We add, and then we add 13 minus x. Then we add x minus 3, x minus 3. And then we add 29 minus x, this one. And then we add 50 minus x. And then we add 32 plus x. And then we add We add just x, this one, and then we add 45. If we add everything, it becomes 174. Okay. It becomes 174. So we continue. Now we proceed because we need to solve this question. We need to now solve, and to solve this question, we find the following. So if you add everything here, it becomes exactly x. Then we get 161. Add all these numbers. It gives 161. I know you can do addition, and it's 174 on the right. So x now is going to become 174 minus 161, which is actually equal to 13. So this is the answer because they asked us to just show that x equals 13, and we have shown that. Okay, so note that. And we have answered this question. So take your time to analyze this question because we shall be moving to another question here together. So to make sure that everything is okay and we are most certainly on the same page together. So we're having this session here. There's another session that's going to start at 2 p.m. So you need to be ready to begin with us as well at 2 p.m. So yeah, be ready there to begin with us at exactly 2 p.m. so that you can learn the mathematics and prepare for the exams, because the exams are here and they are here to catch you. The examiners are here to catch you. They are here to challenge you. So you must be ready to understand the things. How do you understand the things? It's when you can do these questions on your own. So after you watch this video, you must actually look at the question without looking at the answer and make sure you can show that x equals 13. And that is what needs to happen. So if you can do that, then it's actually perfect stuff. It's very, very perfect stuff. So let's continue. Right, so there are some questions they're asking us to calculate the probability. So let us deal with the probability. Now they are saying, what is the probability? Okay, let's analyze the probability. Right, if a student, okay, the rest of the information you already know. If a student was selected at random, calculate the probability that he studies the following: mathematics, physical sciences, but not life sciences. The student does not like life sciences and decides, I want to do only math and physics, but not life sciences. That is their choice. But now, what is the probability? Calculate the probability that he studies the following there. Okay, so yeah, just 2 marks. I'm gonna just bring to the surface again our Venn diagram. I'm gonna be really quick in drawing it. Make sure we don't waste a lot of time. We already know what's happening with the Venn. Right, so yeah, the Venn diagram, and we remember there were events here. An event like this, another event like this, another event like this. Life sciences, physical sciences, the mathematics. Now, this was exactly x without 5, x minus 5, 13 minus x. This was x minus 3. This was 50 minus x. This was only just x. This was 29 without x. This was 32 plus x. This was 45. All right. You ask, if a student was selected at random, calculate the probability that he studies the following: mathematics and physical sciences, but not life sciences. Let us do with that probability there. So that's pretty straightforward. So here we're going to do the probability. I can just do it here. So if we do the probability, for example, that a student does mathematics and physical sciences, not life sciences. So they do M and L, mathematics and physical sciences, but not life sciences. So now tell me, what is the probability here? All right, we already know that x equals 13. So if x equals 13, we are looking at mathematics and physical sciences, but not life sciences. Mathematics and physical sciences, we are here, but life sciences is out. So we're going to be considering only the 50 minus x because it's mathematics, physical sciences, but life sciences from here, it's out. So yeah, 50 minus x is what we focus on. And then we divide by the total. What is the total? The total is 174. Okay, what is x? We already know that in the problem, x is 13, and we divide everything by 174. What is 50 minus 13? Is 37 over 174, which is actually equal to 0.21. So that is the answer approximately, obviously. Meaning that we have that at this point here, we can do the calculations with ease and realize that these guys here are approximately equal to each other. So the probability that a student, if a student was selected at random, the student selected at random, we have to calculate the probability that he studies the following: mathematics and physical sciences, but not life sciences. Okay, so yeah, we have exactly that part. Right, so we have answered 6.3.1 and we got the 2 marks there. Let's look at 6.3.2. Let's look at more probability calculations. If a student was selected at random, so they select a student at random, they just go to the group of the students and they like, let's go to the class. If they get to the class, they just choose one student at random. Either it's a boy or a girl, it doesn't matter, but they just choose one. If a student is selected at random, calculate the probability that he studies the following: only one of mathematics or physical sciences or life sciences is doing only one of the three, only one of mathematics or physical sciences or life sciences. So if you take math, physical sciences, and life sciences, is doing one of these. What is the probability? Okay, I'm just gonna have it here. So yeah, forgive me, please. The Venn diagram is part of what we need to learn. Okay, I need to speak about complementary events and the complement of an event as the region outside the event space. Right, so would remember that I make this oval for me. It makes it easier for me to put much information in the events, in the event spaces. So this one is like life sciences, this one is physical sciences, this one is mathematics. Right, so yeah. So we have x minus 5. Okay, we've already done this. X 29 minus x. We understand y is 29 minus x. We understand y, it is 13 minus x. We understand y, it is x minus 3. We understand y, it is 50 minus x. We understand y, it is 32 plus x. We understand why. We already know that the Venn diagram is like this. If a student was selected at random, calculate the probability that he studies the following: one, only one of mathematics, of physical sciences, or life sciences, only one of those. What is the probability there? What is the probability over there? All right, so the probability, right, the probability P only math or um, physical sciences or L, life sciences. Hey, life sciences you can say LS, okay, or just L in short. Right, so now only math or physical sciences or life sciences. So what is this? What is this? Right, so let's analyze in the Venn diagram. So it's only math, or so in other words, it's only math, it's this one, or this one, or this one. So it means that it is going to become what? It's going to be like 13 minus 5. What is 13 minus 5? It's exactly 8. Or here you put 13 minus 3, which is equal to 10. So plus 13, which is 45. So you have 8 or 10 or 35, right? Very good. Which means that here you'd have 8 or 10 or 45. All divided by 174. And this is exactly 21 divided by 58. And if you use your calculator, this is approximately 0.36. If not just accurately that, but just use your computer there, the calculator, to do the decimal. So yeah, check that, 21 divided by 58. And the answer is 0.36 approximately. Yeah. So now, if a student, what's the probability now? If a student was selected at random, calculate the probability that he studies the following. He does only math or physics or life sciences, or he's just gonna have the probability of 0.36. Next question. That is the end of the Venn diagram question. Okay, let's look at more probabilities and also the idea of independent events and also mutual exclusive events. So let's speak about mutually exclusive first. And then we're going to speak of complementary events. Mutually exclusive. What are mutually exclusive events? So mutually exclusive is when the probability of A and B is equal to 0. These events are mutually exclusive. These are mutually exclusive when the probability of A and B equals 0. Simultaneously, we speak about independent. Independent. Independent would be that the probability of A and B is the probability of A times the probability of B. So this would be independent. Independent means that one. And then we have complementary events. Complementary. You're right, complementary events. Right, complementary events. What are complementary events? Two events are complementary. Normally, we speak about the complement. So in other words, the probability of A complement is 1 minus the probability of A. So these are said to be complementary. So yeah, so you can say the events are complementary if the probability of B is 1 minus the probability of A. So A and B are like complementary events. Okay, just mentioning some things. Let's do this question. I've made space available for this. Next page. Right, so if you look at the two events, A, B, and C are such. The events A, B, and C are such. A and B are independent, B and C are independent, and A and C are mutually exclusive. Their probabilities are the probability of A is 0,3, that of B is 0,4, that of C is 0,2. Calculate the probability of the following events. Let's analyze these together. Okay, probability of, the probability of the following events occurring, both A and B occur. What is the probability that both A and B occur? So we are looking at this question here. We're looking at this question here together. Right, both A and C, okay, remember that we have that A and B are independent, B and C are independent, A and C are mutually exclusive. So which means, therefore, the probability, you need to calculate the probability. The probability of A and C. The probability of A and C is equal to 0. Why is the probability of A and C equal to 0? It is equal to 0. The reason for that is since A and C are mutually exclusive. Are mutually exclusive. There is no intersection. There is no intersection of A and C. Right. So in other words, calculate the probability. They wanted to know what the probability is. Is it probability 1 or the probability? Remember, the probability always lies between what? The probability of anything. The probability of an event is either 0 or 1 maximum. It lies between 0 and 1. Okay, so the probability of A and C occurring is 0 because they said calculate the probability. Why is it 0? Because A and C are mutually exclusive. So the probability is already 0. Why is it 0? Since A and C are mutually exclusive, there is no intersection of A and C. So in other words, if you look at A, event A, and event C, in a Venn diagram situation like this, they don't meet at all. They're like separate. Because they're separate, they are mutually exclusive. They're mutually exclusive. They are mutually exclusive. All right. So that's what we have. That's what we have. Next question. Calculate the probability of the following events occurring. Both B and C occur. Both B and C occur. Right. Remember that the probability of B and C occurring, because B and C are independent, so we already know that it is a probability of B times the probability of C. And these are, the reason is since, why do we write this formula like this? It is true since A and C, rather B and C, since B and C are independent. So now we do the calculation here. The probability of B and C, then you have the probability of B, which is 0.4, times the probability of C, which is 0.2. Right, so you multiply this, which becomes 0.08. So the probability of B and C. Yeah, calculate the probability of the following, both B and C occurring. This is the answer, is 0.08. Why do we use this formula of probability of B and C equal to probability of B times that of C? Because we're told that B and C are independent events. Okay. Next question. Okay, we already know the story, but if we want to find the probability of the following events occurring, at least one of A or B occur. I said we're coming back at 2 p.m. For those who are going to be free at 2, we're going to be doing more at 2 p.m. for those who want to join, or for those who are free. But now I want us to look at 4.3. At least one of A or B occur. At least one of A or B occur. But you know that A and B are independent. Okay, if they say at least one of A or B occur, at least one, it means that either A or B occur. So we're going to find the probability of A or B. Right, so if they say at least one of A or B occur, we're going to find the probability of A or B. What is the probability of A or B? There's a formula, which is the probability of A plus the probability of B minus the probability of A and B. This is the formula for the probability of A or B. Right, this is the formula. So now we're just gonna fill everything in here. What is the probability of A in here? Probability of A is, okay, but first things first, I'm gonna also mention, because obviously in this question, they did not give us the probability of A and B, but they gave us the probability of A, the probability of B, the probability of C. But we can do this. The probability of A plus the probability of B minus the probability of A times the probability of B. Why? Because A and B are independent. If A and B are independent, then wherever we have the probability of A and B, we can put times. We can put multiplication of the probabilities there. Right, so the probability of A is 0.3. The probability of B is 0.4. The probability of A and B is what? Okay, you already know that of A is 0,3. That of A is 0,3 put here. Because A and B are independent, so you can just change these two times. And then now the probability of B is 0,4. Right, so you have this. You have, therefore, the probability of A or B. Right, so what is the answer to this? So 0,3 plus 0,4 is actually 0,7. 0,3 times 0,4 is 0,12. Right, so the probability of A or B, the probability of A or B is the difference of the two, 0,58. 0,58. 0,58. 0,58. So yeah, calculate the probability of the following events occurring, at least one of A or B. Okay, so we have that answer. Right, we've answered this question on the probability, and we are enjoying probability calculations. So we have looked at mutually exclusive events. We have looked at independent events. We have looked at complementary events. Right, we looked at complementary events. Right, we looked at complementary events. Yeah, I'm just recapping on this so that you can remember complementary events. Right, the probability of B is 1 minus the probability of A. Then A and B are complementary events. Okay, right. We looked at these probability calculations. Let's look at something else now that comes in the exams as well. So, but yeah, this morning we are talking probability. Okay, it's not only probability that we need to know. There are like other things that you need to know besides probability. Okay, probability is one of the things, but what other things do we need to know about mathematics? Math is not all about probability anyway. What about other things? What are the other things that we need to know? The other things we need to learn and understand ourselves. These other things we need to learn and understand are the things that pertain probability calculations. Right. Okay, let's look at this question. Consider the word product. This word product. So this is just a question. Let's answer the question about probability. Obviously, it's not directly about probability, but it relates to probability. We need to know how many different arrangements are possible if all the letters are used. We want to form arrangements. So we are learning arrangements. So besides probability, we need to know arrangements. How many different arrangements? How many different arrangements can be made if the first letter is T and the fifth letter is C? How many different arrangements can be made if the letters R, O, D must follow each other in any order? Okay, let's understand and solve the problem. Right, consider the word product. Consider the word product again. How many different arrangements are possible if all the letters are used? First things first, you need to look at the fact that how many P's are there? There's only one P, there's only one R, there's only one O, there's only one D, there's only one U, there's only one C, there's only one T. Now, that is then very, very important. So we want to calculate the how many different arrangements are possible if all the letters are used. So we're going to look at the number of arrangements. Right, number of the arrangements. They want to know how many arrangements. So to calculate the number of the arrangements, we count the letters here. Right, first things first, we see how many. There are 2, 4, 6, 7 letters. So we're dealing with 7 letters. Right, so dealing with 7 letters, then we're going to make a choice of the first letter. The first letter, if we want to arrange them, we arrange them like this. One, two, three, 4, 5, 6, 7. Okay, we have like 7 slots, 7 blanks. We have organized for this. I'm trying to teach this a little bit so that you can like understand the basics of counting and how we do the arrangements in mathematics. Okay, there are a total of 7 letters, and then we ask ourselves the question, how many different arrangements are there? How many different arrangements are there? So we need to make arrangements. So if we want to make arrangements, we can choose, if you want to arrange them, you want to put them in a row. You want to put them in a row. So you choose 1, 2, 3, 4, 5, 6, 7. So you can choose any of them. But the first letter that you're going to place here, you can choose among the 7. So in other words, for the first letter, you have 7 choices. You have 7 choices. After the first letter has been put here, you can choose one of them. Maybe you chose D. Then you have now a total of 6 letters remaining. And so now you must choose one out of the 6 and put it here. So because there are 6 of them, you have 6 choices. 6 choices to make. After that, this has been chosen. Then you have a total of how many? You have a total of 5 letters remaining. Right. So if you have a total of the 5 letters remaining, then what do we do? Okay, we have 5 letters remaining. So in other words, you have 5 choices. You can choose amongst 5 objects. So you have like 5 choices. Okay, I'm trying to teach this a little bit so that some of you can understand the basics because yeah, you're at different levels of math. But some are advanced among you, some are not advanced. So yeah, but this might be new to some of you. The notion of arrangements. So now you have you have chosen 3 letters so far. Maybe you choose D. D is out. Then you're left with 1, 2, 3, 4. So when I have 4 choices to make, you can choose among 4. After you have chosen that, you can remove. Maybe you choose R in any order. Then you can actually then choose among 1, 2, 3. Then you have 3 choices. 3. Okay, after the 3, maybe now you can choose T. T is out. Then you have P and O remaining. So those are 2 letters. So now you're going to have 2 choices. 2 choices. After that, maybe you choose P, then you're left with only O. Then there's 1 choice. There's 1 choice. Right, there's 1 choice. So which means if they say how many different arrangements are possible if all letters are used, so you have 6 choices, 7 choices times 6 choices times 5 choices times 4 choices times 3 choices times 2 choices times 1 choice. And therefore in mathematics, when you have 7 times 6 times 5 times 4 times 3 times 2 times 1, we say you have 7 factorial. We say it is 7 factorial, like 7 factorial. Okay, for some of you might have not seen this symbol like an exclamation mark in English. If somebody's shouting, you put this kind of a symbol in English, but in mathematics, it means a factorial, and it means you are multiplying 7 times 6 up to the number 1. So in terms of the factorial, there are just some examples we can give. Like 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Okay, we can do like 5 factorial is 5 times 4 times 3 times 2 times 1. What is 3 factorial? 3 factorial is 3 times 2 times 1. What is 3 times 2? It's 6. 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12 times 2 is 24. So 4 factorial is 24. 5 times 4 is 20. By 3 is 60. By 2 is 120. So 5 factorial is 120. So 7 factorial can also be computed. You can write the number of arrangements as 7 factorial. You can leave your answer like this. But you can also use your calculator to do the factorial and then get 5040, 5040. In which case, therefore, 7 factorial is the same as 7 times 6 times 5 times 4 times 3 times 2 times 1. Right, so what is 7 times 6 times 5 times 4 times 3 times 2 times 1 is 540. This is 5040. It's 5040. Okay, so we have exactly that there. Right, so we continue and we look at more problems. We solve more mathematics. How many different arrangements can be made if the first letter is T and the 5th letter is C? So yeah, we're looking at the arrangements. So we're gonna put some blanks, but yeah, we need 2, 4, 6, 7. 1, 2, 3, 4, 5, 6, 7 blanks. 6, 7 blanks. Right. So we continue. You have 6, then 7 blanks. So how many different arrangements can be made if the first letter is T and the 5th letter is C? Okay, look. We want to look at how many different arrangements can be made if the first letter is T. So here we're going to put T here. And then the 5th letter is C, okay? 5th. Number 5, put a C here. So we are counting different arrangements, people. So now let's continue. We're looking at the different arrangements. Different arrangements here. The first letter and the 5th. So now it means that if we make the first letter T and the 5th letter C, what do we have? What do we have? Okay, and let's count and calculate the arrangements in mathematics. So in other words, we cut this one out. We cut T out because now, and also cut C out. So we are left with 2, 4, 5 letters to arrange. Out of the 7, 2 are out. What are these 5 letters? So the letter we can put here, we can choose amongst 2, 4, 5. So we have 5 choices in the first slot. 5 choices. After that one, maybe R is out, and then we have 4 choices. After this one is out, then we have 3 choices. Okay. All right. Let me see now. Maybe you cut this one out, then you have 2 choices. After that one is out, and then we have 1 choice. All right. So we continue. We continue. Then we have 1 choice. Right. So 5.2, the number of the arrangements. The number of arrangements is going to become what? Right, we continue. Okay, let us see. Okay, somebody said 5 factorial. Well done. Thank you so much from Poe. Wow, that's awesome. Poe is right. It's already 5 factorial. So the number of arrangements in Poe is right. It's going to be exactly 5 factorial because we just have this. So it's going to be, as Poe was saying here, it's going to be exactly that one. So it's going to be 5 times 4 times 3 times 2 times 1. Very simple. It is therefore called 5 factorial. And if you use your calculator, it's like 120. The number of the arrangements is 120 arrangements. Okay, so we are surely good. Let's look at 5.3 now. Okay, we still have the same word product, but now we are having like a set of different rules in this question. And they're asking us to do a couple of things. They're saying, right, you need to determine how many different arrangements can be made. If the letters R, O, and D must follow each other in any order. They must follow each other in any order. So obviously, let's look at this one here. So you have, obviously, I have to arrange the 7 letters. Let's look at this one. Just different rules a little bit. They're trying to change, but the same thing. So position 1, position 2. Okay, we have 7 blanks for the 7 letters. We need to place them on top of the blanks. So 1, 2, 3, 4, 5, 6. Then we put the 7th letter. And then now we then say, how many different arrangements can be made if the letters, as said, R, O, and D must follow each other in any order? So if the letters now R, O, and D, they must follow each other in any order, what do we have? So we can have a couple of cases like where they follow each other, right? And in what ways can we arrange these letters such that they follow each other? So first, if these ones are to follow each other, we need to first organize these letters so that they follow each other. So, in how many ways can you arrange these letters so that they follow each other in order? So now they are 1, 2, 3, right? like that. So you'd have like 1, 2, 3 letters. You put them here. Right. So the 3 letters, you can start with any of them, you know, so that they follow each other. In how many ways can these be? So you can start and have like ROD, or you can have ORD, or in other words, you can start with the R, you can start with the O, or you can start with the D, R, O, or you can start with, for instance, even if you start with the R, you can start with R still and have DO. Right. So the R, you can start with R and have OD and also have DO. If you start with O, you can have RD, but you can also have DR. So, I mean, the order is different. You're arranging them. So here, D is second place, here, D is third place. So, but obviously we can't always write all these because we are interested in time. So if you arrange the 3 letters now, these ones, they can be arranged in 3 factor ways. So if you look at the ROD, they can be arranged in the first letter you can put here. You need to choose either R, O, or D. So you have 3 choices to make. After that, maybe you choose D for O for argument's sake. Then you're left with 2 letters. You have 2 choices to make. After that, you have chosen, yeah, the second one, D. And then the last one, you have 1 choice to make. You've already arranged these letters here. And then now you need to continue. And now, because how many different arrangements can be made if the letters must follow each other in any order? Any order. So you can start with the R, you can start with the O. So yeah, but I was writing these. So normally we do this, we don't write all these possible combinations. But yeah, you can start with the O, RD, and then it's the R. If you start with D, for example, it can be RO, but you can start with D and have OR. So at the end of the day, you have 1, 2, 3, 4, 5, 6. So this 6 is the same as like 3 times 2 times 1. The 3 times 2 times 1, which is the same as 3 factorial, which is the same as 6, because 3 times 2 is 6. Okay. Now here we come now. So these ones now have been organized and they're like one block. ROD, we like organize them, they're one block, and then we come to these ones. These ones now we are left with a total of how many letters to organize here? Right, so here we're left with, we have a total of 1, because it's 1, 2, 3, 4, 5, 6, 7. So here we're left with a total of, out of the 7 letters, 2, 4, 6, 7, we are left with 4 letters. After we have removed the R, we have removed the O, we have removed the D. So we're left with T, U, C, T. And these are 4 letters that we need to arrange here. So the first letter we can put here can be put here in 4. So we have 4 choices. And then now here, after the first letter has been chosen, maybe P is out, then we have 3 choices for the next one. Okay, after put the third one, then you have 2 choices. After that, we have 1 choice. So now we have this question for 3 marks. In how many different arrangements can be made if the letters must follow each other? These ones are like one thing. But now, so look at this one as one block. So this is one block or one letter. You can look at them as one thing. So we have, in the end, this kind of an arrangement. We have this kind of an arrangement where now you have to draw like this, which means it's one block letter, two, three, yeah, one, two, three, four, five. One, two, three, four, five. Okay. Because these are like one thing, they must follow each other. So you can't mix them with the others first. But if they follow each other, they are like one letter. So which means that the number of the arrangements, the number of arrangements. Okay, the number of the arrangements now, we have a total of 5 letters to organize. 5 letters to organize. Okay, it's a little bit tricky, 5 letters to organize. So you have 5 choices to make. Right, so you deal with 5 choices. And then after that, we have 4 choices. We have 3 choices. 4 times 3 times 2 times 1, because we have, yeah, 2 choices and then 1 choice, which means it is 5 times, which is 5 factorial. And 5 factorial is 120. All right. I want to make a change here a little bit. Right. I want to make a small change to make it easier. So in effect, what we're saying here is you'll have to make the arrangements like this. And then say here is 3 factorial multiplied by, okay, 3 factorial for the ROD, and then now you'd have 5 factorial for 1, 2, 3, 4, 5 letters. So these 3 factorial is 6, 5 factorial is 120. If you multiply everything, it becomes 720. So how many different arrangements can be made if the letters must follow each other in any order? It's a little bit tricky, but please just learn it. It's 720. Next question. Next question. Okay, we're looking at like more probabilities now, but one thing that you need to learn is the idea of a tree diagram. Okay, we looked at two-way tables, we looked at the mutual exclusive events, we looked at independent events, we looked at the Venn diagrams, but we are looking now at something we call a tree diagram. What is a tree diagram? We analyze a tree diagram together. Right, to do tree diagrams now, we're going to do them like this. We're going to do them like this. We're going to do them like this. Right, so the probability that it will rain on a given day is 63%. A child has a 12% chance of falling in dry weather. And okay, let's read this. So yeah, we're gonna do it on the next page. I've made enough space available for us to do the tree diagram, the probability that a child will not fall on any given day, and the probability that a child would fall in dry weather. But obviously, let's just maybe get a sense of this question about the tree diagram and what they want us to actually do here, what the examiner is asking, because these are like from past exam questions. They're not questions I just decided to bring. These are past exam questions. The probability that it will rain on a given day is 63%. So the probability that there is rainfall on a given day is 63%. A child has a 12% chance of falling in dry weather, and is three times as likely to fall in wet weather. Okay. So in other words, children fall all the time because they are still small, but they are still learning how to walk. So the children, sometimes when they're walking, they fall down. So this question from the examiner was looking at the children falling when they're walking. But here's a child. A child has a 12% chance of falling in dry weather. So if the sun is out, the child has a 12% chance of falling. But is three times as likely to fall in wet weather. In wet weather, is three times. It's likely to fall more, three times when it's wet. Okay? Because the rain makes the surfaces to be wet. Draw a tree diagram to represent all outcomes of the above information. Let's look at the tree diagram here together. Let's look at the tree diagram here together. We analyze this. Okay, I'm just doing this. I want to ask you about tree diagrams, probability. You understand probability more. That's what the discussion is about today. Right. So in 3.1, let's draw the tree diagram here. The probability that it will rain on a given day is 63%. A child has 12% chance of falling in dry weather and three times is likely to fall in wet weather. Draw a tree, or three times is likely to fall in wet weather. If it's wet and it's rainy. Right, because sometimes it rains, sometimes there's rainfall, sometimes there's no rainfall, sometimes the sun is out. Okay, let's start. We start by looking at the fact that either there's rainfall or there's no rain at all. So we agree that either on a given day there's no rain, or on a given day, basically we agree that there might be rain. Okay, let me put it here. So on a given day, there might be rain. On a given day, there might be no rain. No rain. Okay. Fine. Write that properly. No rain. So, right. So let's continue. But what is the probability that it will rain on a given day is 63%. So the probability of rain is 63%. So if the probability of rain is 63%, what's the probability of no rain? The probability of no rain is going to be 100% minus 63%. 37%. So the probability of a child falling, the child might fall, the child might not fall. Either the child falls when they're walking, or the child does not fall. So a child has a 12% chance of falling in dry weather. Right. So let's analyze this one here. So either the child falls, either the child will fall or the child does not fall. Okay, we're just learning the tree diagrams here. Right. So normally they have two situations, either it rains or it does not rain. Okay. Let's look at this carefully. A child has a 12% chance of falling in dry weather. Okay, let's look at if there's no rain. If there's no rain, then it's dry. And the chance of the child falling is 12%. And the chance of the child not falling, if 12% is the chance of falling, not falling is going to be like 100% minus 12%. And this is exactly 88%. So it's like the complement of that. Falling and the not falling is like the complement of that. Okay, let's analyze this one. So no rain and fall is the outcome. No rain and fall is the outcome. Here is no rain and not fall. No rain and not fall. No rain and does not fall. Here the outcome is there is rain and the child falls. So rain and fall. Here is there is rain and the child does not fall. Okay. Right. So we have this tree diagram. What is the probability that now when it's raining, the child falls? What is the probability here? A child has 12% chance of falling in dry weather, 3 times as likely to fall in wet weather. So it is 3 times 12%, which is 36%. And therefore, it means that the child will have a 36%. A 36% chance of falling in when it's raining, and therefore it's wet weather is 36%. But the chance of not falling is going to be like 64%, which is like the complement of that. Because when you add these two, you must get 100. 30 plus 60 is 90. 6 plus 4 is 10. It's 100%. So these are complementary events. Falling, not falling are complementary events. Okay. So complementary events, if you add them, you get 100%. 1 or 100%. Okay, they said draw the tree diagram to represent all outcomes of the above information. This is it. This is the tree diagram. You need to draw it like this in the exam, and you get 6 marks if you draw it like this. We're just learning tree diagrams. If they don't ask you the two-way tables about the broken limbs we did, or they don't ask you about the Venn diagram, they can put a tree diagram there. Or they put none of these three. Okay, these are the tools. So yeah, we've learned the tree diagram. Next question. What is the probability that a child will not fall on any given day? The child does not fall on any given day. Right, so let's look at this question. Right, remember, I'm just going to draw these quickly because we can only do this if you look at the tree diagram. So either it rains or there is no rain. The rain is 63% chance. No rain is 37% chance. And then this one here is 36% chance. And this one is 64% chance. Okay, 36% chance is a chance of falling or not. The child might not fall. Either the child falls or the child does not fall. Either the child does fall or does not fall. So either there is rain and fall. Okay, we drew this here, but I want us to calculate the probability here. So we need to see the tree diagram. So the rain and not fall. Yeah, either there is no rainfall and the child does fall, because the children, when they're walking, they can fall even if it's not raining. So there's no rain and the child does not fall, does not fall down when they're walking. So we have this. What is the probability that a child will not fall on any given day? 3.2. So let's calculate that one. The probability that the child does not fall. Okay, so now let's look at this one here. Remember, what is the probability that the child will not fall on any given day? So obviously on any given day, there are two possibilities. Either that day it's raining. So if it's raining, it is 63%. 63% is like 63 over 100 times. Okay, remember, what is the probability of that the child will not fall? If it's raining, for instance, if it's a rainy day, what is the chance there of the child falling or of not falling? Is 64%. So either it rains and the child does not fall. So raining is 63%, does not fall is 64%. Or we put a plus. Either it rains or it does not rain. If it does not rain, what is the probability that it does not rain on a given day? It's 37%. 37 divided by 100. Right? So we also have a situation where the child does not fall. Okay, it does not rain, but the child also doesn't fall. Right, obviously we did this one here. It was 12% and 88% respectively. So it does not fall is like 88%. Yeah, 88 per 100. The probability that the child does not fall. Okay, so if you calculate this one, it's a 64 and the 63, you divide by 100, it gives 252 over 65. Plus, now you look at this 60, at the 37 and the 88, 407 divided by 1250. The probability that the child does not fall. So if you add this up, you'll get 911 divided by 1250. Use a calculator. The probability that the child does not fall. Right. Probability that the child doesn't fall. Not fall. 0.7288. 0.7288. Right, so we have this. Okay. So yeah, what is the probability that the child will not fall on any given day? The probability is 0.7288. So yeah, just look at that and think about it. One more question on the probability. What is the probability that a child will fall in dry weather? The children fall even if there's no rain. So obviously, the children, they don't just fall if it's raining, but sometimes it's not raining and the children, boom, they fall down. Okay. So let's analyze that together. Let's start. Okay. The tree diagram already know. So allow me, please, to just sketch it quickly. And sketch it quickly like this. And sketch it quickly this way. And put some percentages here, like your 63%. You can put 63% here. You can put 37%. You can do rain. You can do no rain. And then you can do 36%, 64%. And then you can do something else. So obviously it's either the child falls or does not fall. Either they fall or they do not fall at all. In which case, then you have those here, it's 12%. Here it is exactly 88%. Right, so at this point, what you get in here is that you can have a situation where it rains and indeed the child does fall. So here you can have a situation where it rains and the child does not fall. In every situation where there is no rain and the child falls. Can have no rain and the child does not fall. Okay, Yeah, okay, we have an idea of the tree diagram there. And now let's find the probability in 3.3. Right, the probability that a child will fall, they will fall. So we look at the four cases, but the weather is dry. So now we are focusing on no rain, no rain. So it's dry weather. So which means that at this point, we're gonna look at this here. The probability of dry. It's dry and the child does fall. Okay, if it's dry and the child does fall, um, right, so we're looking at no rain. So yeah, the probability of no rain is 37%. Where is 37, 100? And the child falls down. Boom, fancy, falls down. 12%. 12%. Boom, the child falls. Okay, 12%, you can just put 12 over 100 because the percent means divide by 100. So yeah, you can just put 12 over 100. Right, I said this is recorded. So in case your network is bad, please know that the video is going to be posted. So if you multiply everything here is 111 divided by 2,500. And this is 0,0444. And this becomes the probability of dry weather and falls down. Right, so yeah, about this. So know that, so we have this here. Let's see now. Okay, I've kept it on air for all this time. Let me look at the next question. Right, the next question is about sequence and series. I just brought a question on sequence and series, so let's just try this one quickly, and then I'm going to release you, and then I'm going to be back at 2 p.m. for those who are free at 2 p.m. But we shall take a break quickly after this question. The sum of the first n terms of a geometric sequence, 9 plus 6 plus 4 is greater than 25. Calculate the smallest value of n. So obviously here we're looking for something because it is a geometric sequence. So we have something called a constant ratio. We call that R. Second term divided by the first term. Second term here is the number 6. The first term is the number 9. The answer, it is therefore divided by 3, 2 times, 3 times. So, which means we have that, but obviously we're dealing with the sum of the first n terms, so we're dealing with the summation. Right, dealing with the summation. 1 minus r to the n divided by 1 minus r. So with n is the first term is the number 9. The constant ratio is 2/3 to the nth power divided by 1 minus 2 over 3. And obviously this is greater than 25. Okay, so yeah, we need to solve for n out of this. And so we're just dealing with sequence series. I'm going to release you, please, after this question, so so that you can have a break and relax and enjoy yourselves a little bit more. Right, so if you manipulate everything here, I'm not going to waste a lot of your time there, but it becomes 2 over 3 to the power n less than 2 out of 27. That's what it becomes. All right, if we solve for n out of these, you take the log both sides. So it becomes the log of 2 over 3 to the power n, and then the log of 2 out of 27, which means n, the log of 2 out of 3, the log of 2 out of 27. So now we need to solve, make n the subject of the equation. So we divide both sides. You have the log of 2/3, and then you have the log of 2 out of 27. You divide by the log of 2/3 divided by the log of 2 over 3. The inequality is going to change direction like this. Okay. Why does it change direction? Because we're dividing by a negative number. Because if you look at the log of 2, 2 is smaller than 3. So if you use a calculator and you're going to do the log of 2 over 3, it doesn't have a negative, but doesn't look like it has a negative, but it is negative. Okay, because if you look at the log of that, that is the log to the base 2. So if you do the log of that, it becomes exactly something. So you're dealing with the log, right, the log of 2 divided by 3. Right, so you have approximately minus 0, 17609, like this. 0,17609. So it is indeed a negative number. So in mathematics, if you divide by a negative number, the inequality, if it's less than, it must change to greater than. So that we have that n is strictly bigger than. Right, so if you use a calculator, you will get approximately 6, 41902. 41902, which therefore means that we are looking for calculators more or less the value of n. So if n is strictly bigger than 6, 4, this n is the number of terms. So the number of terms obviously is a whole number. So which means that we have the smallest value of n, which is actually 7 there. Okay, so that is the answer. The answer is 7 terms. Okay, so we had to deal with the sum of the first n terms of the geometric series. This is greater than 25. Okay, so yeah, they just use the word sequence, but I must indicate, please, that this one is a series, because in mathematics, a series means a sum. A sequence would be 9, semicolon 6, semicolon 4, and so on. Okay, so just something for you to note, but I've taken this question from some material. But yeah, okay, so the person did not type it correctly. It should have been a geometric series because of summation. But yeah, we're done with this. Guys, I must thank you for joining us. The time now is actually exactly 12:16 p.m. on Sunday. It's a beautiful Sunday, and the date is what? The date is the 29th October 2023. Okay, and it's a sunny day outside. and there's no rain outside. Okay, I must thank you for joining us. Please, we're gonna be back again at 2 p.m. for those who are free. If you're free, I'm gonna send this. It's the same link, so you can join and then we continue. Yeah, thanks a lot, guys. I'm gonna post the video in a couple of minutes. Enjoy your day so far. See you at 2 p.m. for those who are gonna be free. Thank you and goodbye. Goodbye, guys. Goodbye.